Welcome back. It's time to wrench on the Doll 366 again. Today I want to make the governor and the water pump. However, first of all, I'm going to finish off the engine itself by putting some oilers in places where they're needed. The rest of the pump is very similar to the bearing blocks for the valve gear, so I've already went ahead and made that. Now the final piece on top, which the pump gets clamped into, will need a radius in the middle, and I've just went and chucked a piece in the forejaw and have a scrap on the other end so that I don't cut into the jaw, and we'll just plunge in there with a milling cutter and see how that works out. So the pump holder is all dolled up and ready to go. Now we need the clamp to go on top of it. Maybe you still recall my die, if you want to call it that, from the Doll 362 build. Well, I'm lazy too, so I'm just going to use this once again, because it works fine. Ooh. Second attempt, now with a different stuff. This is the gummy kind of aluminium, which is really a bear to machine. The other one was a lot more free machining, but I reckon that's because it's brittle. Let's see. Yep, there we go. Not a problem. Ta-da! The governor is going to be an exciting piece. whole bunch of pieces which of various degrees of difficulty in themselves, and then it all needs to be soldered together and worked out. So we're going to try and start with the base, which is a turning piece, and then gets a notch cut into it for this piece to be soldered onto. But one step at a time. The bevel gears for the governor are module 0.4, so half the size of those that drive the valve train essentially. I've already quote-unquote modified my tool holder so I can mount a module 0.4 milling cutter in here. Stupidly in the wrong axis. Had I drilled it this way round, then I could have just clamped this thing without, well, interfering with the shaper. Now the hole is in there, so nothing that can be done. Before I do anything, however, I have a tremendous run-out problem on this 100-odd years old 3-jaw chuck. I have no means of clamping this, I have no means of finding out whether this even runs true to the spindle or whether the spindle is bent as well. So what I'm going to do, instead of grinding it out the proper way with a jig, rotating this around and clamping something, I'm just going to do the poor man's method, take the jaws out, which are the low point essentially, and grind them away a little bit, and chuck a piece, see if that improved the run out, and then repeat the process until this is, well, I mean, I would be happy if it was less than 1/10 of run out, especially no angular error, because that's what this thing has got. Run out is, well, almost tolerable right at the beginning, and then the further something sticks out, the worse it's going to get. Which just speaks for bell mouthing. So yeah, let's do that. Right at the chuck, jaw number 3 seems to be the low spot by about, shall we say, 3.5 tenths. So if we take 1.75 tenths of a millimeter off, that should bring us closer to the truth. Also, take a look at this tremendous amount of bell mouthing. I think we'll have to correct that first before we can get any reliable numbers on runout, because if we now just grind 1/10 off here, then well, the pattern on which the bar is grabbing is going to change completely. A few hours later, this is probably about the best I can do. I've noticed that there is quite a jump in this shaft and there's some play in the bearing as well. So what I've done is go from jaw to jaw, clamp it down, that's 72. Go to the next one, clamp it down, that's 72. Go to the next one, clamp it down, that's 71. And most importantly, if we go way out here, and we're at, shall we say, 88. We're at, well, shall we say 98? And we're at 98. So all the way out here, it's only about 1/10 of a millimeter of wobble. And for probably really 100-year-old piece of kit, I am absolutely fine with that. The bell mouthing is gone, so there is no noticeable wiggle in the jaws now. Also by the yellowish shine here, you can see that the jaws are actually contacting on the entire length now and not just on some tip way in the back. I can feel that I have to tighten the chuck a lot less tightly in order to get some proper grip on here. And I feel like we have a fair chance of getting somewhat of a true gear profile onto our bevels now. So here's the setup we're running. Obviously, since I misdrilled the hole for 90 degrees, I had to put something in between here in order to get it all to line up. Freshly refurbished 3-jaw chuck on here, blank chucked up. It's now running about 1/10 of a millimeter out. I think that's okay for a decoy of a governor. And I've got my table ready to measure out the degrees here. And well, we'll just keep on going around the circle and feeding in and crunching the numbers, and that ought to put out a gear. For the very last bit of exhaust here, I need a piece of 6mm tubing to do a rather shallow bend, and since I need to have this narrow walled, because otherwise these two exhaust ports are just going to build a massive overpressure trying to exit through here, I can't just bend it in your regular tube bending device, it'll just kink. So I've taken this bit of tubing and filled it with sand and kinked the edges over in hope to seal this tightly in here. And now I can hopefully use some sort of a die and clamp this in the vise, and bending this will just be a breeze. And this has been annealed, of course. That's about 120 degrees, right? And it kinked.
Another one.
For the longest time I've had this tube bender lying around, never used it because it seemed so sloppy and flimsy and unusable, but let's give it a try here. See what it does. Oh yeah, it works beautifully, yeah. Okay, so those are all the tricks I know. It didn't work, so if you have any suggestions how I can make this piece here, dimensions are right here, 6mm tubing, some sort of close radius like 12mm, 10mm, the closer the better. Then I'd be very glad about your suggestions, because I'm going to have to make a few other rather complicated pieces of tubing, and that's not going to work. Now the two tubes coming from the exhaust side of the cylinders, they're a little bit smaller, and for the large radii I just made an impromptu tube bender, hoping that this is going to work out. This is thinner tubing, so maybe it's got a higher chance of working, I don't know. I've put a drill bit in the end here, so that I can maybe feed this in here and have this be my guide, and then do the radius around here. And this works very nicely, wow! You need to go to right about there. Now the reverse bend is a lot tighter, and for that I just bought myself this chintzy little thing, which was never designed to do this sort of, with a radius already in it, so I have to remove one handle, but then it's just going to thread in fine, and we can chuck this end up. And do our bend as far as we desire. A little bit farther than that. Yep. And this is how the exhaust tubes are going to sit. Now, once again, for this last exhaust piece here, I'm going to need your help. Can I make another tube bender like this for larger tubing and just give it that kink? Is there some physical boundary as to how far I can bend a piece of tubing like that? Should I maybe use copper tubing? I don't know. Anyways, thank you very much for watching this episode. Sorry I didn't make any videos for so long. Sometimes life just gets in the way. And, well, I hope you enjoyed. And I guess in the next video, we're just going to quickly solder this all together. And then take it apart, get it painted, and get all the non-painted pieces nickel plated, and then we're going to move on to the boiler, probably in the video after that. Until then, thank you very much for watching, and see you guys next time. Bye bye!